Hello, ZX White, who may or may not be there. I am... Hello, ZX White, who may or may not be there. Turn that off. So, yeah, what you see me here is playing Final Fantasy VI, or 3 if you're in the US. I go by Gwydion, or Gwyd, if you will. Okay, good. I have to, grind these guys, because they're really not powerful enough to, defeat Ultros, who's coming up in here. Fortunately, I have the Bannon to, keep giving people health. Don't have the eye drops to cure his blindness. And why is the stream not going on? Delay. Sorry about that. There's a bit of a delay, bit of lag time in this. Is this on? Is this? You know what? I could drop the lag time by doing some USB tethering. So which one avoids the Ultros and yet that way? There we go. So okay, there we go. That's the way. Yeah, I'm sorry. I'm still having to relearn parts of this. Yes. And there we are. That should do it. But yeah, the whole point is someone wanted me to tutor chemistry. So, I came in with intent to talk about chemistry. While she was here, but she didn't seem to be here. Seems to be a ZX White in here. ZX White? Perhaps left on? Water did. I'm guessing ZX White probably left that on while I was hosting someone else. Or something to that effect. There's an awesome Amanda who was supposed to come in and actually listen to me tutor chemistry. I thought I'd be interested in talking about things. Learning, very good, yes, but is not here. Listen to, she is. So yeah, I guess I just have to sort of wait for her to come, although I can talk a bit about chemistry. One of the things you learn in chemistry is, of course, about atoms. These small singular units. As a matter of fact, there's a bit of learning about the etymology, that's word history, that goes into that. The word atom actually basically comes from the Greek word singular. Singular thing that, can exist on its own, and without any other principles. It's just its own individuality. That was Ultros. So, okay, that is Ultros. Okay. Don't tease the octopus, kids! I may lose and have to go back for my thing. I don't know. I don't think the guys are... Ah, there she is! Awesome Amanda! How are ya? Concerned I wouldn't see ya. Hey! As you can see, the game I'm playing here is Final Fantasy VI or 3 in the US. I already have actually been streaming a little while and mentioned that, but we just came in, so probably a bit of a delay, something to the effect of a few seconds. But yeah, it's still cool to see you in here. What's up? There'll be a bit of a delay. I'm sure you've responded by now, but I haven't seen it yet. Everything okay? Is the noise, okay? Can you hear me all right? And the music's not too loud or anything to that effect? It doesn't work on him. Nothing much. My stream is perfect. Well, then that's wonderful. Fantabularific. So, yeah. You wanted to learn about chemistry. I mean, I don't know where to start. Normally I kind of let the other person dictate that. Oh yeah, that was me. That was me trying to get into the room and get everything, running, and that sort of deal. So that yeah, that probably, when it went offline, that was probably what happened. Me coming in, getting started, and didn't quite work. I'm sorry. I'm so sorry. I'm so sorry. I didn't mean for it to be bad. I tried to make it and... No, not chemistry, just what you would major in if you went to college. Okay. Well, I mean, I talk about a lot of different things. I mean, I'm a very educationally oriented person who's often very curious and looks things up. I've often been told I'm like a walking encyclopedia. I get curious and I want to know why things are a certain way, so I will, look things up and end up learning. So often there's ideas like etymology, which is word history, that comes up. I get very curious about, hey, why does this word mean that? Where does it come from? Does it come from another language? Was it invented in society or something like that? Was it based on a person's name? That happens quite often. If you've ever heard of the concept of a... Oh, no, I don't... I tutor a variety of things. Chemistry is like the main thing. She asked if I tutored chemistry, if you couldn't watch and see this. No, I tutor a wide range of different things. Chemistry is like the main thing because it's like the primary thing I do professionally. Matter of fact, it's funny because my name, Gwydion Magus, that I use in as, sort of as a character, is almost like a wizard's name, who many people say, yeah, kind of like, it would be sort of like a Severus Snape, sort of an alchemist type. So, no, I tutor a wide range of things. Is there something you'd like to learn about? Something from mathematics, perhaps? Well, I was talking about something in, something that actually is a type of mathematics that when, if you've been learning, there's that political thing that I'm having a hard time remembering right now. what do they call that? That standard political thing, that way of learning, that oh gosh, I just cannot remember the name of it. And I did a video on it where I was playing Phantasy Star, and I was actually talking about it, and I actually typed it in, the concepts. I did, see, that's what I'm talking about. Like, it's going on and off. I need a better computer with better attachments is what I need. There is a Common Core learning. That's what I was trying to remember. There's a thing from mathematics based on that I was doing when I was teaching when I was playing Phantasy Star. Matter of fact, I can get Phantasy Star back up again. I don't seem to be doing too hot in this. Well, what the hell? I'll just die and go back. Whatnot. Okay, I'm back. Thank you. I'm glad I'm back. I don't know why it's having such a hard time. It's hooked in on two different realms here. Which way? Did I go left before? Okay, I'll go up now. But yeah, it's something from Common Core that I realized from being a scientist. I realized what the use of it was, where it could be useful to learn for people. And it relates to mathematics. It has to do with bases of counting. And that's probably something you don't even know about, counting in certain bases. You're 900 years old, you are counting in bases, you will know. Pardon, it's me being a goofball. I'm going to do that because I'm going to try to entertain you. If you find something funny or not funny, please let me know. But, yeah, we get used to counting in a certain base, and that base is 10. And people are like, well, of course. As a matter of fact, heck, you'll see the numbers on here. Right here I'm pointing to the 0 on Final Fantasy. Well, what we get used to is we get used to this idea of having 10 digits that, in the ones place, what's called the ones place, that represent different numeric values. And people say, well, what's the importance of that? I says, well, why do we necessarily have to have 10? Well, 10 was decided on a long time ago. And people, I said to myself, well, why 10? Well, look at your hands. And take a look at how many digits you have. You have 10 digits. So, and as a matter of fact, what we learn is based on an Arabic system. I know that's strange. People are like, what? Arabic? Yeah, we actually count in what's called the Arabic numeral system. These numbers were developed a long, long time ago in an Arabic country. And yeah, that's interesting. And we have 10 digits. You have 0, 1, 2. I don't have any 3s on here, but you get the idea. Up through 9. Oddly enough, when you get to 10, instead of there being an extra digit that represents 10 values, you move to the left. So this is the tens place, and this is the ones place. Yeah, okay. And that's real simple, but they're teaching little kids this right now in this Common Core concept. And people often don't see the point of it. Well, here's the idea. When you get 10 tens, 10 times 10, you move to the left again. So you get to the 100s place. And when you get 10 100s, which is 10 times 10, right, and you get 10 of those, 10 times 10 times 10, or 10 to the third power, you go to the thousands place, which is the next one to the left. And so on through. So when you see the number 232, what 232 is, 2, here I'm going to write it in here so you can see it on the chat, times 10, the second power, plus 3 times 10 to the first power plus, now I mentioned the 2 times 10 to the 0 power. 232 is, you should have seen that appear in your chat. It appears. Okay, it looks like Twitch ate it. Let me try that again. Sorry, it does that sometimes, eats messages. No, there it is. Okay. That's what the number 232 is. 2 times 10 to the second power plus 3 times 10 to the first power plus 2 times 10 to the 0 power. Anything to the 0 power is 1. So that's the ones place. Pretty neat, huh? If we were counting in base 2, we would only have 2 digits. 0 and 1. Alright? And the number 101 in base 2 is 1 times... Okay. Well, you'll get this when I get back. Sorry, I'm going offline again. Plus 0 times 2... Yeah, I know I'm going offline again. I'll try to get back up. I'm doing my best here. Okay, I'm back. Well, what I was explaining is, if instead of counting in base 10, we counted in base 2, 101, as you see up there, would be 1 times 2 to the second power, plus 0 times 2 to the first power, plus 1 times 2 to the 0 power. And it makes sense because something to the 0 power is the ones place, and it's going offline again. Yeah, this is probably happening because I'm competing for bandwidth right now. And I don't have a particularly powerful computer, so I just appreciate people being patient with me. I try to be patient with others. Yeah, I know, I'm back. What you're getting is I'm competing for bandwidth right now. This is happening. You know, doing my best. But the thing I was trying to show you is how, just like the number 232 in base 10 is, you know, as you can see in the chat, is 2 times 10 to the second power plus 3 times 10 to the first power plus 2 times 10 to the 0 power. 101 is 1 times 2 squared to the second power, and it makes sense because that first 1 is 2 spaces to the left of the ones place. So you know that it's times 2 to the second power, because it's 2 to the left. And then the 0 is times 2 to the first power, because it's 1 to the left. And then because the last 1 is in the ones place, it's times 2 to the 0 power. So that would be, and if you could watch me use the pointer to point at these, but I don't think it can because it only captures the pointer when I go over here. But if you saw that, you get the idea that 1 plus 2 squared, that's essentially 4, plus 0, plus 1. So 101 in base 2 is the number 5. But of course we count in base 10. So we, you know, just have a single digit that represents 5. So, you know, instead of writing 5 like this, 101, in base 2, we write it as 5. if that makes sense. So numbers are just a matter of how we write them, how we decide to represent them. If that makes any sense.
If makes sense, this does. Because talk like Yoda I can to make it more interesting for you.
Or perhaps you'd like to hear it as though I was the Duke, and I could talk like I was John Wayne. You hear that the 2 times 10 to the second power, because that's 2 times 100, plus 3 times 10 to the first power, because that's 3 times 10, plus 2 times 10 to the 0 power, because that's the number 3. You really would like that, wouldn't you, cowboy? I wonder if I've gone offline again. I'm not getting a response, but too much competition for bandwidth. Urgh. And that's a neat little thing you learn in math. Alright. Well then, people wonder, why do you do this? Why do you need to learn this in Common Core? Well, there's a real simple reason why you might learn this in Common Core. In scientific writing, which you might learn in chemistry, the number 232 might be represented like this. .32 times 10 to the second power. That's called scientific notation. And if you understand how writing things in base 10 and understanding how base 10 actually works, where it's a digit times 10 to a certain power and a digit times 10 to another power, you would understand that the first digit on the left there is 2 times 10 to the second power. And then because it's one digit to the right, that 3 is basically 3 times 10 to the first power, because it's 1 to the right. So instead of it being times 10, and then that 2, because it's 2 digits to the right of the first digit. So understanding how base 10 works helps you to understand how scientific notation works. And scientific notation actually has a purpose. And that actual purpose has to do with statistics. If that makes sense to you. Yes, and even the vampire voice which I speak with it like this right now understands that scientific notation has a point, it does. Scientific notation, the point of it is to understand where you're rounding. You see, if I say a person is 132 centimeters tall, alright, what I'm really saying is that I'm fairly confident that they're somewhere between 131 and 133 centimeters. They're in a range. Alright? I may not know exactly where. They could be 132.5 centimeters. They could be 131.8 centimeters. I don't know exactly. I'm just confident that it's somewhere in that range. Well, the concept is I only want to write down the numbers that I'm sure of. Alright? Well, what if they're only 130 centimeters? What if I'm only sure that they're somewhere between 120 and 140 centimeters? What if I'm only sure out to that range? Alright? What if I'm only sure to that? Well, what I could write is, I could write 130, but there's a problem with that. When I write it that way, it looks like I'm saying it's somewhere between 129 and 131 centimeters, which is not true. I'm somewhere between 120 and 140 centimeters. Alright? But what I could do is write it this way. (1.3 times 10 to the second power). Which is 130. But I don't have to put that trailing zero in. And the reason is because when I write it this way, that zero is really just functioning as something called a placeholder. But if I write it this way, I don't have to use the zero as a placeholder. So, wow! There's actually a point to learning something in Common Core. There's actually a point! Because it helps people to understand scientific notation. Yeah, Common Core actually has something useful in it. I'm willing to bet a lot of other things in Common Core are actually very useful. Yeah, the Common Core thing, the thing about bases and stuff like that and rounding, it's also teaching you sometimes stuff about statistics that you don't even really realize. Like, you know, rounding and ranges and stuff like that. And this is just breaking it down into its base parts. You know, explaining why the different pieces. So it's like, wow, yeah, that actually has a point! Yeah.
Has a point it does. When 900 years old you are, understand the point you will.
Yeah, awesome, isn't it? It's pretty cool. It's awesome, like Awesome Amanda. Alright, and that scientific notation, yes, is actually part of chemistry. You know, because you have to do scientific notation in chemistry. You have to write things that way and understand what it is. And it sometimes helps if you've been presented it in a funny way. The other thing that also helps you deal with scientific notation when you're doing stuff like chemistry is it helps you deal with very large and very, very small numbers. Because you have to do that in chemistry. You have to work with extremely large and extremely small numbers. Alright, you might have to work with, and here's a good one, oops, I did it wrong. It's supposed to be 6.022 times 10 to the 23rd power. 6.033. Looks like I'm not having bandwidth problems so much anymore. Alright. That 6 that you see there, alright, would basically have 23 zeros after it. And, you know, that's just inconvenient to write something that way. You don't want to have to write out, you know, all the digits of Avogadro's. There's more digits to it. It's like 6.02215927773. You don't do that. We're often not sure out to that many units. We're only sure out to a certain number. So yeah, the 6 would have 23 digits after it, 23 zeros after it, plus a 0 with 22 zeros after it, plus a 2 with 21 zeros. You get the idea, right? So we want a more convenient way of writing it. And you also have things like this. (1.23) times 10 to the -4. Yeah, sounds strange, but it's true. Yeah. Well, what that is... Error? What error? Also, I'll post this on YouTube so that you can, you know, come back and watch this later, or even just listen to it. Sometimes listening to it helps too. Yeah, I have a name on YouTube as well, Gwydion Magus. Well, I'm just Gwyd1 on here, which is an abbreviation of that. So you see, even I used an abbreviation. You thought what problem was an error? 1.23 times 10 to the -4? You thought that was an error? It isn't. It's just representing a small number. What that is you take that decimal point in between the 1 and the 2, move it 4 spaces to the left. So 1.23 times 10 to the power of -4 would be equal to 0.1234. That. And that's taught in Common Core as well. How many eye drops do I have for this guy? Do I have eye drops? Yeah, I do. Let's try that. Yeah, while I've been grinding these guys, they've been getting eye drops. So yeah. So scientific notation lets you work with very large and very small numbers. And that's the whole point of learning about these powers of 10, right? And it kind of makes sense, because just like I talked about, you know, 132, which is, or 273, which is 2 times 10, you'll see this appear in a moment, second power plus 3 times 10 to the first power. I'm sorry, 7 times 10 to the first power plus 3 times 10 to the 0 power. Alright? Just like there's that, or 2 times 100 plus 7 times 10 plus 3 times 1, which is, 10 to the 0 power. Alright. You can also have fractions, decimals, things like 0.123, which is 1 times 10 to the negative first power plus 2 times 10 to the negative second power plus 3 times 10 to the negative third power. Raising something to a negative power is the same as dividing by it, or whatnot. So multiplying something, just like you can multiply something by 10 squared, which is 100, you can also divide something by 10, which is the same thing, or divide something by 100, which is the same thing as multiplying it times 10 to the negative second power. So yeah, understanding how this works lets you work with it. Mathematics. And people don't get this because they're never taught that, because they're kind of expected to already know it. They're expected to already know that multiplying by 10 to the negative second power is just dividing by 100. And they're never told that. No one ever teaches them that. And now, in Common Core, they're trying to teach kids that. Yeah, that makes sense. Teach them something that you would think they'd get on their own, but why would they? Why would anybody get this? We're taught to work with it, but we're never taught where it comes from or why it works. Understanding where things come from and why they work is important. It's critically important. But people don't have the patience to sit down and understand what it is they're learning or why they're learning it. They just expect people to already know it and to already get it. Pretty neat stuff, huh? So, you see, that's part of the problem. Sometimes what people need is they need to be explained to, on purpose, at length. And they have to have the patience to want to sit down and learn and comprehend. But they often don't unless they have colorful things moving in front of their face, like a video game. Which is fine. There's no problem with that. So, hey, why not provide it for them like I'm doing now? And then, of course, the other thing you have to get into when it comes to this is the metric system. Or the Système International, sometimes called the International System, but that's based upon saying it in French. The SI system, or SI International System, or Système International. That has to do with the fact that French comes from, Latin-based language. And And now we in English, of course, speak what is sort of a Germanic-based Slavic-type language. In Germanic-based Slavic-type languages, the adjective comes before the word. So we say red dress. Well, if we were speaking a Latin-based language, the adjective would come after the noun. So they would say dress red. Which seems unusual, but, if you grow up speaking, Spanish, for example, you get kind of used to that idea. You get kind of used to the idea that the adjective should come second. Alright. That's been problems in the way people communicate before, is they don't know that. That's never explained to them. Okay, I'm sorry that you have to go, but, that's good that I got a person to talk to. It's nice. Anyway, I have to save state this anyway, so... Good to speak with you. Have a good one.